Assalamualaikum. My name is Muhammad NASIF bin Ahmad Shairi. My matrix number is AN220042 and I will explain how to answer the question number 1. Okay, the question given is d to y over dx square plus 3 dy over dx minus 4y equals to 10e power of x minus 250 cos 3x. So first we need to determine the characteristic of the equation and find the general solution for differential equation. We use the formula b squared minus 4ac. We plug in the value of a, b and c, then we will get 25. And it showed it was a real and different roots. Then we use am squared plus bm plus c equals to 0. We follow the equation, so we will get m squared plus 3m minus 4 equals to 0. Then we get m negative 1 and m plus 4 equals to 0. So m1 equals to 1 and m2 equals to negative 4. So we find the complementary function yc is equals to c1 e power of m1x plus c2 m power m2x. So we plug in the value of m1 and m2 to the yc. So we will get yc equals to c1 e power of x plus c2 e power of negative 4x. Next, we will use y equals to yc plus yb. Complementary solution plus particular solution. We need to choose a correct yp according to the type of fx. So yp equals to yp1 plus yp2. So the f1x is equals to 10 e power of x and the other is f2x is negative 250 cos 3x. So for the yp1 equals to xr in the bracket k e power of x, while yp2 is equals to xr in bracket alpha cos 3x plus beta sin 3x. Then we substitute r equals to 0 into the chosen yp and check either the term in yp correspond to any term in yc. So r0 yp1 we substitute r with 0, so x0 in bracket k e power of x, so we will get k e power of x. So it shows it's same with c1 e power of x plus c2 e power negative 4x. Then we substitute with r1, r equals to 1 and check again. So x1 in bracket k e power of x, then we will get k x e power of x. Then it show it was different with c1 e power of x plus c2 e power of negative 4x. Then we will use y equals to k x e power of x. Then we need to find the first and second integrate of the y. Then we will, after the integrate, we will get first integrate, we will get k in bracket x e power of x plus e power of x, and second integrate we will get k in bracket x e power of x plus 2 e power of x. So from the equation we just need to substitute d2y dx square and dy dx, which the first and second integrate we get. After we substitute with that, we substitute it, we will find the k, and k is equals to 2. So we take the equation y equals to k x e x, we substitute k with 2, so we will get y p1 is equals to 2x e the power of x. Next, we will find yp2. yp2 is equals to xr in bracket alpha cos 3x plus beta sin 3x. It was similar to the how do we find the yp1. So first we need to r equals to 0, then we substitute r with 0, so we will get y equals to, we will get alpha cos 3x plus b sin 3x. So the equation is y is equals to alpha cos 3x plus beta sin 3x. Then we need to find the first and second integrate for y. Then we substitute it. Then we will get negative 9 alpha cos 3x minus negative 9 beta sin 3x plus 3 in bracket negative 3 alpha sin 3x plus 3 beta cos 3x minus 4 in bracket alpha cos 3x plus beta sin 3x equals to negative 250 cos 3x. Then we rearrange it and we will get negative 13 alpha plus 9 beta equals to negative 250, and negative 13 beta minus 9a equals to 0. So then we need to find the value of alpha and beta. Then we will get alpha is equal to 13 and beta is minus to negative 9. So the yp2 is equals to 13 cos 3x minus 9 sin 3x. So next, y is equal to yc plus yp1 plus yp2. So we plug in all the value we get from yc plus yp1 and yp2. We will get c1 e power of x plus c2 e negative 4x plus 2x e power of x plus 13 cos 3x minus sin negative minus 9 sin 3x. So y0 is equals to 13.13 equals to c1. So we just c1 e of 0 plus c2 e negative, we substitute x with 0, then we will get c1 plus c2 is equals to 0. So c1 is equals to negative c2. So dy dx equals to negative 13 and x equal to 0. So from the equation, we just need to substitute it, dy dx with negative 13 and x with 0. Then we will get negative 13 equals to negative 5c2 plus 2 minus 27. Then we will get c2 is equals to 1. So we can get C1 is equals to negative 1 because C1 is equals to negative C2. So we just need to all the value we get to the y, then the answer we will get y is equals to negative e the power of x plus ex plus 2x e power of x plus 13 cos 3x minus sin 3x.
Assalamualaikum and hello everyone. My name is Haddad bin Nasrake. My metric number is N220032. Here I will present the question number 3, which is using suitable method find the general solution to the differential equation, which is d squared y over dx squared plus 4 dy dx equal to 5 sin 3x. And then we substitute the dy dx into m, which we got m squared plus 4m into 0. A with A equal to 1, B equal to 4, with C equal to 0. And then we factorize the quadratic equation and we got the m1 equal to 0, m2 equal to negative 4. And then we use the b squared minus 4ac to find the whether the equation, the result will be equal, more or less than 0, which we got the result more than 0. And then we use the yc equal to a exponent m1x plus b exponent m2x, and then substitute the m1 and m2 into the equation, and which we got wc equal to a plus b exponent negative 4x. And then for the second phase, we will use the fx equal to 5 sin 3x and yp equal to sr multiplied with k cos 3x plus l sin 3x. And then using the r equal to 0, we substitute the r into the equation, the yp equation, which will get k cos 3x plus l sin 3x. And then we derive or differentiate the yp, and then we will get negative 3k sin 3x plus 3l cos 3x as a first equation. And then we derive again the previous equation, which is the first equation, into the second order, which we get negative 9k cos 3x minus 9l sin 3x as the equation 2. After that, put the 1 and 2 equation into differential equation, which we will get bracket negative 9k plus 12l close bracket cos 3x plus bracket negative 9l minus 12k sin 3x equal to 5 sin 3x plus 0 cos 3x. And then from the cos 3x and sin 3x, we will use the simultaneous equation, which is negative 9k plus 12l equal to 0, and negative 12k minus 9l equal to 5. And then For the first one, we need to multiply with 12, and then the bottom one was we're gonna multiply with 9 to eliminate the k. And then after that, we will get the negative 108k plus 144l equal to 0, and then the bottom one, negative 108k minus 81l equal to 45. After we do the subtraction, we will left with 225l equal to negative 5, and then we will get the l with negative 1 over 5, and then we substitute the l with the value we have got, which is negative 1 over 5, and we will get with k equal to negative 4 over 15, and then we will left with yp equal to negative 4 over 15 cos 3x negative minus 1 over 5 sin 3x. And to find the y, we must plus yc with yp, and then we will get the general solution a plus b exponent negative 4x plus negative over 15 cos 3x minus 1 over 5 sin 3x. That's all for me. Thank you.
Assalamu alaikum everyone, my name is Haddad JABERI. My metric number is AN220211. Here I'm going to present to you second order differential equation. From this chapter, I'm representing to you question number 4 from our assignment. Our objective is to find the particular solution for the differential equation. Our equation is d square y over dx square minus 2 dy over dx plus y equal to 6ex, or exponential power of x. What's worth to notice here is it's not equal to 0, which make the second order differential equation is not really homogeneous, so it's non-homogeneous equation. So we will have to take two different type of y in order to find the general y. So here we start first finding yc, which is the complementary function, and r, its value. So from the question we can find that a equal to 1 and b equal to minus 2 or negative 2 and c equal to 1. So what we need those numbers. In order for us to find the complementary function, we need to make the equation as if it is a homogeneous equation. So we find that we make it equal to 0. So after that, we need to check from which case it follows in the homogeneous cases. So by taking b square minus 4 times a times c, we will find out that it's equal to 4 minus 4, and it is equal to 0, which is following the case number 2. If the b square minus 4ac equal to 0, then it's following case number 2. If it is more than 0, it's follow case number 1, and it's less, is follow case number 3. So here we already determined the case. We next go to find the r, or the value of r. As you see here, that we change the whole equation from differential equation until like a normal problem, which is r squared minus 2r plus 1 equal to 0. And we need to find the root of r, which is like r minus 1 is the only root we can find, which makes r equal to 1. So now we already have the value of r. From our previous case, like it follows case 2. From the case, we find that it follows a specific type of complementary function, which is yc equal to a plus x times exponential the power of rx, which we can find it at the bottom of the slide. This equation is follow only case number 2, and unlike that, we reach to our complementary function. Next, in order to find the y, the general solution, which is a combination of yc, and which is the complementary function, and yp, the particular integral, we need to compute yp. Yp is basically the similar or the equivalence answer from different like we need to compute it from our answer. So from our answer which is 6x, we refer to the particular integral table to find its equivalence. So as you see in the left side, our answer is really similar to number 2, which is c times e to the power of alpha x. In order for us to find the equivalence, we need to take xr times p times e alpha x. So we will take this the equivalence function. So here we assume some numbers for r in order to differ it from yc. As we see before, the equation we have already, which is x the power of r times p times e alpha x. Here we're gonna assume the r of the x in this step. So we first assume that is equal to 0. So it's gonna be x the power of 0, which is equal to 1, times p, which is a constant, times e the power of x. As we compare it to the previous or the complementary function, we will find out that p times e the power of x is equal to the one part of the complementary function, so it's not really valid to use in the next step. So we're gonna assume another number for r, which is 1, and after we plug in 1, we will find, you can see at the bottom of the slide that the yp is equal to x times p times ex, e the power of x. This equation is also similar to one term in the complementary function, which also make it not valid to use. So we continue to assume r equal to 2. Here, after we assume that r equal to 2, we find out that the equation is not really similar to the complementary function, and from this point we can continue to find the yp, or the complementary integral. Okay, in order for us to find the yp, we need to find the value of the arbitrary or of the constant p. So we will need to substitute it in the original equation, And in order for us to substitute it there, we need to find the derivation of this equation. So the first derivation of px squared times the exponential time the power of x equal to 2px times ex plus px squared ex. Because it's a product rule, because x square and ex are two different following two different x, and the second derivative is 2px 2p ex plus 2px ex, also 2px ex plus px square ex. Now we already have the derivative of our y, or py. So we substitute it in the original question. It will appear like that. 4px ex minus 4px ex plus 2px x square ex minus 2px x square ex plus 2p ex. Actually, as you see here, guys, I just like organize the question, because if I just like substitute it directly, it will be very messy and it's not gonna be like obvious for you to know that there are many terms gonna be cancelled. So as you see, 4px ex is gonna be cancelled by equivalence, like 4px ex, and 2px square ex is gonna be also cancelled. So the only term is gonna remain with us is 2p ex, which is equal to 6ex, the real answer. So after taking off after dividing by ex and dividing 6 over 2, we find out that p is equal to 3. So now we substitute it in yp. So it's going to be 3x square ex. Now we find yp and yc. We need to find the general y, which is the combination of yc and yp, as we can see at the bottom of the slide. So yc is a times ex plus bx times ex. This is yc, plus yp, in which is equal to 3 from the p above, times x square ex. And here we can stop if we need just only the general solution for this equation, but we need the particular solution. So we need to refer to the points, or the initial points, that the teacher gave us, or the question gave us. The initial point, the first initial point was y equal to 0 when x equal to 0. So after substituting, we can find out that all the terms gonna be cancelled, or all the terms will equal to 0 except a, because it's not multiplied by x. Just the exponential is the power of 0, which make it equal to 1, as you see in the equation in front of you. So at the end, we find out that a equal to 0. Next, we have another point in order for us to find b. So we need to substitute, or to derive first, then substitute, because dy over dx equal to 2. So after derivation, we find out that dy over dx from our general solution is equal to a the power of ex plus b power of ex also, plus bx ex plus 6x ex plus ex 3x squared. Now we have the value of y prime, or dy dx. Now we substitute it with 2, and we substitute the value of x with 0. And again, after all or after we substitute, we're gonna find out that all the terms are equal to 0 except to a power of ex plus b times the power of ex, which both make the equation equal to a plus b equal to 2. And from previously, we know that a equal to 0. So 8 plus b equal to 2 is gonna be b plus 0 equal to 2. That makes the value of b after we substitute the a equal to 2. Now we got the values of a equal to 0 and the value of b equal to 2. So now we can substitute it in the general equation to make it finally the particular solution for our equation, which makes y equal to 2, which is the value of b, times x times ex plus 3x squared ex. And like that, we could find the particular solution for our equation. Thank you for listening, and Assalamu alaikum.